Okay, halfway through. Question 11 is an exponential equation question. You should recognize it for what it is. It says the concentration of a drug in the body can be described by the exponential equation C as a function of T is equal to C naught e to the minus lambda T. Forgive the formatting of this. The lambda and the T is quite small here, sorry. Where C is the concentration in percentage weight volume in the blood at time T. C naught is the concentration immediately after intravenous injection of the drug. And lambda, which is this funny sign here, is the drug elimination rate. Linearize this equation. In other words, write it in the form y equals mx plus c and describe what you would need to plot on the axis of a linear plot in order to determine a value of lambda and C naught from a linear regression. Okay, so what am I going to do? Well, it's got an E in it. And I know that the ln of E is equal to 1. That's going to be useful for me. So I might start by taking the natural logs of both sides. Let's do that. So ln of C T is equal to ln, use a curly bracket here, C naught E to the minus lambda T. Okay. Okay, so I can't really do anything here. That's as good as it gets. But I'm going to separate this out using my summative law of logs. That's the same as C naught plus ln e to the minus lambda T. Okay. That's as far as I can go with that one. I can expand this out further by using my power law of logs. Let's write that term back in. I know that if I've got an exponent here and I've got a natural log in front of it, I can take the exponent down in front of it to multiply it, which the word I'm looking for here is linearize it. And I'm left with ln e. I've just told you that that is equal to 1. So if I rewrite this whole thing, that's equal to ln C naught minus lambda T. Now we're almost there. Remember what we're trying to do here. We're trying to write this in the format of a straight line graph, form of straight line, y equals mx plus c. Okay, so you've got, this is a constant, so there's your c. Here's your x, it's your t, that's your variable, which means that the gradient is minus lambda. So let's write that out explicitly. I'm going to rearrange this in this form, equals minus lambda t plus ln C naught. Let's write that out explicitly. That's your y. Mx plus c, where y is equal to ln ct. M in this case is equal to minus lambda. We know x is equal to t, and we know that your constant, in other words, where it intercepts the y-axis, is equal to ln C naught. So if you were trying to describe what you need to plot on a straight line graph, I'm going to plot my y as ln C of t, and I'm going to plot t along here. Remember, it's a decay, so I've got a negative gradient, and the point where it hits that is ln C naught. And if you can fully describe that, in fact, if you can do everything I've just done, even draw the graph, I'm going to give you 8 marks. Okay. Question 12. Okay. This one is also worth 8 marks, I believe. Oh, it doesn't say. Cut and paste it. This is worth 8 marks. Okay. So, the Q10 temperature coefficient, a dimensionless quantity, is a measure of, I'm recording this, is a measure of the rate of change of a biological or chemical system as a consequence of increasing the temperature by 10 degrees. Where R1 and R2 correspond to the rates at temperatures T1 and T2 respectively, the equation above can be used to describe the respiration, in other words, the O2 consumed with units of milliliters per hour of a mink. Using the measurements in the table below, table 2, calculate A, the Q10 coefficient for 4 marks, and B, the respiration rate at 13 degrees for another 4 marks. Okay, let me get my notes up. Okay, so you can take logs, you can take natural logs. It doesn't really matter. I'm going to take natural logs of both sides of this equation first, and I'm going to solve for Q10. There is another way to do it, but I'm not going to show you that. I would rather you did it with your logarithms rules. So I'm going to do, again, log R2 is equal to log R1 Q10 to the power T2 minus T1 over 10. That's all in the exponent there. I'm going to on this side here, I'm going to use my summative log rule to get log R1 plus log Q10 T2 minus T1 over 10. Going further, I can't do anything more with this one, but I can expand the next one further using my power law, bring the whole exponent down and linearize it. I get T2 minus T1 over 10 log Q10. Remember what I'm trying to do here? I'm trying to solve for Q10. So let's get rid of this term. Let's take it over to the left. Log R2 minus log R1 is equal to T2 minus T1 over 10 log Q10. And actually, I can use my subtractive rule here and combine this like this. I'm also going to sort of take 10 over by multiplying and take get rid of the T2 minus 1 by dividing. So that's going to be 10 over T2 minus T1 equals log Q10. Okay, so I've done it pretty much. So actually what I'm going to do first is I'm going to plug the numbers in and I'm going to calculate log Q10. So let's plug those numbers in, shall we? Right, so R2 was 24.4 over 14.2 multiplied by 10 divided by 24.3. Oh, was that right? Yeah, that was right. 9.20. That gives me a value for log Q10 of 0.156. That's got to be to 3 significant figures. Why? 3 sig fig, 3 sig fig, 3 sig fig, 3 sig fig. Brilliant. Okay. And to get, that's log Q10. To get Q10, I'm just going to go Q10. That must be 10 to the power 0.156. That is 1.43. Again, to 3 significant figures. Okay. That was 4 marks, right? My next part of the question was, what is the respiration rate at 13.0 degrees C? Okay, so I'm this time going to use this T1 term again, but I've got another I've got a different T2 value. Oh, sorry, different T2 value of 13 degrees. I'm trying to work out what the respiration rate is. Okay, so I'm just going to plug that into the equation. So R2 is equal to 14.2. Is that right? Yep, 14.2 times by the Q10 that I've just calculated, 1.43, all to the power of T2, which is 13.0 degrees, minus 9.20. And of course, that's all divided by 10. It gives me a value, I do it on my calculator, 16.3. Again, 3 significant figures, 4 marks, if you're consistent with your significant figures. Okay. Oh, I've forgotten something. What have I forgotten? My units. The units were milliliters per hour of O2. Okay. Question 13. Okay, so the ratio, so probability, hooray! Right, the ratio of brown to white mice in a total population of 500 is 1 to 3. What is the probability of selecting 6 mice without replacement? That's the important bit, okay? For the population in the following order: white, white, black, white, black, white. Okay. So first of all, how many black mice are there? Well, if I want to express that as a ratio, then to calculate how many black mice there are, I divide 500 by 4, which is 125, and then multiply by that 1 by 1, which is still 125. So black to white is 125. And calculate the number of white mice, that's 500 divided by 4 times by 3, which is 375. Okay, right. Now, to calculate the probability of getting this selection in this order, is simply, well, what's the probability of getting a white mouse? That is 375 divided by 500. Okay, and then if I don't put that mouse back, what's the probability of me getting another white mouse? This time it's 374 divided by, I've got 1 mouse less, that's 499. What's the probability of getting a black mouse? Well, I haven't taken any black mice out yet, so that is still 125, but I've taken 2 mice out already, so that's 498. Then what's the probability of another white mouse? Well, this time it's 373 divided by 497. Another black mouse, that's 124 over 496. And then finally another white mouse, that's 372 over 495. Do that, you get something like 0.0, I think it was 195. Okay, that's most of the marks, but correct number of significant figures, 3, 3. Your answer, you should be expressing it to 3 significant figures. Question 14. Okay, I always love these, but I always forget how to do them. So make sure you can do a Punnett square before you go into the exam. Let's read the question in rabbits. Hang on a sec, guys. Hang on. Okay. In rabbits, white fur, capital W, is dominant to black fur, lowercase w. And long ears, capital E, are dominant to short ears, lowercase e. Breeder makes 2 rabbits that are heterozygous for both traits. Okay, what is the chance the offspring will be black with long ears? Okay, so let's do this. Right, how many permutations have I got here? Okay, well, I can have from a single parent for both those traits. I can have dominant in the fur color and dominant in long ears or ear length. I can also have that. I can also have that. Of course, I can also have that. Okay, and because I'm taking 2 rabbits with the same Genotype, it's the same in this column here. W, E capitals, and then I've got W, E. Oh, I never give myself enough space to do these, so make sure you give yourself enough space, right? Lowercase. Okay. Okay, so then it is a case of plowing through these. This and this, I get this, which is essentially dominant for both traits. So it's black and long ears, sorry, white and long ears. This one I'm going to get W, W, E, E, W, W, E, E, and then W, W, E, E. Yes, that's correct. And let's have a look. Keep going, Rob. Come on. W, W, E, E, and then W, W, E, E. I've got W. Stay with me. Okay, fully recessive there on the ear length. W, E, E, W, W, E, E, W, W, E, E, W, W, E. Yep. And I've got W. And lastly, of course, fully recessive. Right, so the question is, what is the chance that the offspring will be black with long ears? So for them to be black, they have to be fully recessive. Okay, so they need a lowercase w for the color phenotype. So how many of those do I have? And then for them to have long ears, they can be heterozygous or fully dominant in E. So anything with at least one capital E in it is good. So let's have a look. So this is good. It's going to work. That's going to work. What else have we got? I made a mistake. Have I made a mistake somewhere? No, I was right. It's those three. Mine is shutting down. Just those three means that I've got the recessive color. So it's going to be black. And I'm going to have the dominant ear length, which is long ears. Okay, so the probability there is, oh my, you should see what the weather is doing outside. Gee whiz. Okay, so the probability there is 3/16. Okay, right, what's the next question? Right, so I think the next questions are to do with stats. So I'm going to stop the video here, and we're going to polish off the rest of the paper, which is just about stats. Now remember, there are only 18 questions on this mock. There are going to be 20 on the exam. Okay, pause it there.